This is Will from Bright Studies. I recently posted my solution to this integral, and this was originally posted by Integrals for You on Instagram. Now, the solution that I already posted I consider to be optimal. Basically, there's three options here that I can see. One option is don't do any tricks, don't do any substitution, just charge straight into the integration by parts. That's definitely one way to go. Now, other than that, other than charging straight into the integration by parts, the other thing you can do is say, well, okay, we'll say that's not x. We'll say that's e to the ln of x, right? And then what we'll bring in here is 1 over x times x. Well, let's make things a bit more convenient for our purposes. That's not times x, that's times e to the ln of x. Okay, great. Let's say that. So that's one way you can do it. Then you do this substitution, obviously, right? You've got the derivative of ln of x. So now you've got e to the 2u times u squared. That's an easier integration by parts. Now, there's another way to go. I'm going to show a third way here using the Tomos trick that leads to an even easier integration by parts than that one I just showed. However, doing the Tomos trick and doing all the steps, it's so conceptually tricky, right? It demands, it demands the algebraic mastery here to do it, right? To do it efficiently. So for it to be worth your while to go the Tomos trick and do it all that way, you can't, you can't be wasting too much time seeing how to do the Tomos trick, or else this isn't optimal. But if we can do it, quickly enough, then this could potentially be an even faster way. So we do this, that's x squared, that's 2x. To maintain equivalence, we've actually got to multiply by 1/8. Now you've got the u-substitution. So now we go to the next one. Okay, so this is certainly another integration by parts we go into here, the ln of x times the ln of x. That's another way to go. I wouldn't go that way at all. I would do yet another substitution and go for an even easier integration by parts. So what we're going to do here, right, we're going to bring in the 1 of u, and this, of course, is e to the ln of u. And what are we going to do now? We're going to substitute the ln of u. Okay, so now we just have e to the v times v squared. So now there's no avoiding the integration by parts at this point. But the integration by parts you will go into from here is far easier than the integration by parts you could have gone into, starting with something else. Because what it is, okay, beautiful. So that too can, of course, come outside of the integral, and now you're dealing with a ridiculously easy integral, right? And so the reality is, this is what I'm talking about. So this becomes a way easier integration by parts because this integral right here, the variable times e to the variable, that's very easy to remember as essentially like a common integral, right? So now we go to the final step. Okay, because the one I underlined in red there, the v, it's such an easy integral to remember what it is. That's the easiest integration by parts, right? If we go any other way on this problem, we're going to be in a relatively tricky integration by parts computationally. This one, you can rely on memory so much more, so you're not doing some tricky computations where you can make a mistake. And now, like, frankly, it's like we have the answer, right? Given that v equals the ln of x squared, right? We go back to what it is, right? The ln of x squared. So done, pretty much, right? You can factor out an e to the v. there you have it. Hope you enjoyed this one, guys.